Hello students, welcome to the model number 3. We are going to discuss about entropy concept and also we have to prove that it is a property of system. Okay, so we derived all this concept and finally we have to conclude that energy is also a property of system. Let us discuss how we are going to derive this equation and we have to prove it. Okay, so entropy is a property of system. How it is property of system? Because so on PV diagram or TS diagram, we observe that so anywhere on this point you can define the entropy value. Okay, so we are going to discuss now. So consider a two reversible path A and B joining the state 1 and 2. Okay, so if you are taking the two process, okay, from 1 to 2 and 2 to 1, so following by the path A and B. So if the path B is reverse, that is transferred from 2 to 1, the path A and path and B constitute a reversible cycle. Okay, once if you form a from the two process you forming a cycle, then we can write it as cyclic integral of delta q by t is equals to that integration of 1 to 2 is delta q by t, that is for the path A, plus integration of 2 to 1 delta q by t from the path B. Okay, so once if you know this the different process and constitute form a cycle, then we can write it as integration of 2 to 1 del q by t path B is equal to integration of 1 to 2 del q by t by path A. So because cyclic integral of delta q by t is 0. Okay, so that is for according to Clausius inequality or theorem. So that value is 0. So we have to equate these two equations as equal, and this applies to any reversible process joining state from state 1 to 2. Then we can write it as cyclic integral or integration of 1 to 2 del q by t for the reversible is equals to change in entropy. So it depends upon the that is a reversible process, and it proves that it is a change in entropy. So if change in entropy is possible, so only when the reversible process we are considering and it is equal to 0, the delta q by t is equals to 0, then only the entropy changes, that is S2 minus S1. So thus what we conclude that from this explanation, the entropy depends upon the path, and therefore the entropy is a point that is point function. Hence entropy is independent of path. So it is not bother about the at what manner it is moving. It is followed by the that point where it is located for the particular change in properties. So hence we can say that it is a property of a system. Okay, it is not at all dependent on the path. So we can say now therefore entropy is a property of system. So this is about the proof of entropy. Okay, only very simple step is you have to consider two process and may constitute a cycle, and consider for the reversible process. If you consider for the reversible process, that value is 0, and equate the individual path followed by the process, we make it equal, and apply the reversible process for joining state 1 and state 2, and then it produces a change in entropy. If the change in entropy is happening, so we can say the entropy is a property of system, and it is also point function because it is not followed by the path, it is independent of path. So we can say it is entropy is a property of system. I hope you understood this concept. So thanks for watching this video.